Good afternoon, everybody. I take this opportunity on behalf of EDS Technologies to thank you all for taking your time off to attend this session. So the objective of this session was primarily focused to help to plans to improve the productivity during the COVID, the challenging times that we are encountering. So my name is Karthikeyan. I will run through the slides along with my colleague, both Chirag and Kaladar will take it over at the later part of the session. The next slide, please. Okay, yeah. So before we go ahead about the subject of the today's topic, I would like to briefly introduce about EDS Technologies. EDS Technology has been a premium leading CAD/CAM CAE PLM company incorporated in the year 1994, headquartered out of Bangalore. And we have 11 offices across the country to help to serve the customer in close proximity. In terms of the product portfolio that we carry towards in our organization, it is the leading numero uno products of the world. So today's our subject would be on what you call Dassault systems. So what the product portfolio that we would like to cover using the Dassault systems portfolio of digital manufacturing. And we have 1,500 customers for the last 25 years. This year we are celebrating our 25th year. We have got 1,500 customers to our site, and in terms of supporting, in terms of relationship that we are enjoying today, we should thank many of the customers are today in our session. They will agree and understand and acknowledge. As an organization, we have also built with a model that is coming in new. We have all built a new e-learning platform to help customers to learn in this COVID time, in the pandemic time, that people can learn from their home. In terms of technology, we classified in many domains, both on the CAD tool domains, as well as our e-learning platform is rich on the domain courses too. So I'll invite all the people who are attending the session can visit our edstelearning.com website to take advantage of our portfolio that is available in that platform. We also have a good integration skills. We have been working with many institutions, both DRDO labs as well as government institutions. We have demonstrated our system integration skills for many of the complete system delivery that we have delivered in the past. So this is a brief about our company. If you see one of the symbol that is standing there is a platinum partner. We have been a platinum partner for Dassault Systems, which means that to come to this level, we need to have a kind of a credentials in terms of relationship that we enjoy, the amount of business that we do with Dassault Systems, the number of customers that we take into our portfolio. As an organization, every company has its own product verticals. In this particular slide, we classified our portfolio in terms of what is our market need, what is our customer needs are. So the PLM is our primary focus today that we are going to talk about. So our primary portfolio is 3D Experience product portfolio, CATIA, Simulia, all the product brands that complement the PLM story that we wanted to sell and support in this market. We are also playing a big time in mining space, where we have certain specific technology solutions that would help us to support mining customers. We also do a visual simulation, which I talked about a system integration in the earlier slide. So that is possible because these solutions are primarily available and supporting many DRDO customers for the network-centric warfare, simulator building, information, terrain building. So that's the reason why the visual simulation solutions are primarily adapted in this specific DRDO functionalities and the government and defense projects. To our site, we have newly added the EDA verification tools, which is very recent portfolio in our system. Synopsys is our portfolio. So any customer would need a Synopsys kind of products. We are here to support them in terms of both sales and after sales support. I talked about e-learning in Rich. We have classified our courses in both domain courses as well as the CAD courses. So this helps us to get our customers ready for the future ready, especially in the market dimensions are changing. So this technology that we have in e-learning portfolio would help them to get ready for the future. So we also have services complementing to the product sales. We have 3D Experience platform, and the Innovia is a core PLM platform, where we need to have an implementation strategy very clear to complement the product sale that we happen in the market. So this is typically a internal segmentation that we have done in terms of go-to-market. Next slide, please. So the agenda of the subject, just I introduced about EDS Technologies and what we are and what we do and how we can support in your business. But coming back to the main agenda that we have, we wanted to just touch upon the current industry challenges. What is the as-is industry process that mainly followed in your premises and factories? And what are the points that we need to take up, ponder in the current scenario of factories? What are all the way forward possibilities? How a virtual factory can be the best model to go forward in terms of what do you call evaluating your alternatives. And then we have a customer case study in that slide, which my colleague will explain you. And we also explain the solution benefits and what portfolio and offers that is end of the session. There will be highlighting that options in this. So I am just coming back to the industry challenges here. I'm sure the people who are attending the sessions today would have either encountered in their own internal meetings, or they would have read something in the newspaper or in the news media about there is what are all challenges that organizations are going through. The sudden spikes in demand after the phase of low demand. So there are certain unpredictable demands are coming in terms of the last 3 months. There have been a lull. Suddenly there is a spike in certain business requirements. The rich sector could be the farm sector is trying to take up, and if your business is catering to that business, can really see a kind of a spike in the new demand. Lack of labor, I wouldn't say the labor is lagging, but there are migrants of labor are created some kind of a skill distribution, or what do you call the skill as disseminated from the current place wherever it is supposed to be. So lack of labor is another challenge typically many industries are now going through, and every organization and every state government and union government is trying to see how to facilitate this labor back to the respective locations. The change in layout of social distancing because of the COVID situation, there are minimum 6 feet between the two people who have to interact in either in shop floor or in public places. So this is also putting a little bit of pressure to the manufacturing industry, how they can facilitate maintaining the social distance, but still they will be able to produce the parts or manufacture the components in their shop floors. There are companies thinking about how to repurpose their own shop floor, how to reconfigure, because there are changes because of the resources that have come into picture, constraints on the resources, constraints on the demand. So these are all the factors, what you call defining the new changes requirement that needed in the current manufacturing setup. The customer demand, I talked about in the volatility. There are some customers talk about after sales service markets are demands are good, OEM demands are little low. So there are kind of a shifted priorities in the organizations, creating new ways to evaluate their requirements and see how which component to be produced, which part to be produced more. So all this volatile demand is also putting a lot of challenges to the industry today. That we have any challenges, every organization aspirational view is to be competitive in the market so that they stay relevant in the market and compete in this business. I am sure these challenges are the challenges we will face now in future too. So we have to get ourselves future ready in this kind of challenges. Deriving maximum output, it is nothing but an input output ratio, what we call an efficiency factor. The efficiency factor plays with predominant role in many industry, be it a machine material. Efficiency can be derived if you have maximized with the minimal resources, you are highly efficient in terms of your setup. So this is the process which I wanted to talk about. So we are going back to the history. It is not the history, it is currently prevailing in some organizations in a very dominant way. The as-is process we can't change, but we wanted to see how the businesses are run in the current factories. I am sure entire shop floor today or the process layouts, typically what we call the blueprint document, or it is all existed in a physical blueprint or in a 2D form in an AutoCAD form or a DXF or a DWG form. So it is a typical, any companies will have their complete shop floor footprint in this form. And I'm sure all the companies have a living legacy So there is a lot of expertise that are available in the shop who have worked with the organization for many years. So they bring in their experience, their expertise, and their learnings play a dominant role in terms of what to do in terms of challenges. So they are one of the key enablers in this whole process in terms of decision making, and they contribute in terms of value in what next steps to be done if we need to do any changes. Second thing is the process flow chart, PFD, what we call process flow diagrams, which we normally create based on whether it is the batch production or whether it is the U-shaped production or it is a flexible manufacturing system. Depending upon the maturity of your business process and your shop floor model, you would have adapted this in this process. If you see the next, if you see, we have three PPR: the product, the process, and resource are the primary factors in any organizational manufacturing. In order to get the uh, process and resource mapped very effectively, which is involving equipment and manpower, to get the required or high efficiency product to be manufactured in your shop floor. So this is a factor. So we are taking the resource as a constraint model due to COVID. The processes may be inflexible because there's a fixed lines in the shop floor. So it is putting some kind of a constraint to the shop floor plant managers and the organizational CEOs to make any changes, major changes. So this is the typical constraint model that we are all going through. One side is on the resource constraint, other side is on the process validation constraint. So if you go back, there are points to ponder. As this process we have highlighted here, if you look at it, is the COVID impacting my production? If you can self introspect and if you can ask the question to yourself, is there a way that if it is impacting me heavy, in what form? Is there a way that we can definitely evaluate a best practice during this pandemic time? Why? Because an adversity is an opportunity for every industry to explore. So this is the time that companies also doing self introspection about their own product, process, and resources. Are we ready? And with the critical resource challenges that we are having, are we prepared for the tomorrow? Because we don't know the tomorrow is so uncertain. It can change anytime and it is changing very dynamically. So are we ready? So these are all the questions that are running in many of the people mind in terms of the organization. Can we arrive at a best production pattern using virtual tin? The whole objective today, you will see, and in the coming conversation that you are going to hear from my colleague, the virtual twin will be the one which will enable you to play with in order for you to make a good decision. So in that way, these are the points that will be addressed or covered during the next few slides that we will be going through in terms of illustration and evidences. So the way forward, we had a points to ponder. There is a way forward. You will hear these words like agile manufacturing. That means my manufacturing need to be nimble with minimal resources. My ability to really model with the lean resources, I'm able to produce what is required for me to fulfill my end customer requirement. Can I do an optimum workload managing, keeping the social distancing norm in mind? Can we still address with the less resources? Still, I will be able to meet my possibilities. Is there a possibility that I can run 2 shifts with the reduced workers? So these are all the things that can come in your boardroom meeting or in your production planning meeting. Can I run additional shifts required? Will it give me a desired output or throughput, or still we will have some more challenges? Can I outsource volume to the vendors? That means as a company, I don't want to touch anything. I will look forward for outsourcing. There are many possibilities and different what if scenarios for maximizing unutilized or underutilized resources will be the one which you need to make decision not on your shop floor but on the virtual twin. So the whole objective is never play with your physical infrastructure unless until you are very convinced about the virtual twin with what if scenario studies can enable you to make the informed decisions. And production plan and fluctuating demand is the one problem which we have already highlighted in the assess process and the business challenges. So the way forward is we should be get ready for how to meet the fluctuating demand with available resources, so that without I go for any additional capital investments in the shop floor in terms of machinery and material. So these are all the thoughts that I wanted to set the platform for all of you to soak in the idea what this webinar is about and how our technology and solution would help you to take it forward. So I will introduce my colleague Chirag. He will take it forward with regard to the virtual factory.
Thank you. Thank you very much, Karthi sir, to set a great platform for me to introduce a virtual factory over here. So I would start with the word where what is virtual factory means. Virtual factory means you have your own current physical setup in your computer or in your PCs in a virtual world where you have normally you're seeing a 2D drawings and all of that or plant layouts and all, but now it's time of a 3D factory, 3D digital twin from your 2D layouts itself, not new things. And you can simulate that particular factories in a factory flow simulation where you can simulate your factories in a real time real way, and with the virtual commissioning how you can commit the your setup in a virtual way, how you can change it, like Karthik said, what if scenarios means how you can actually change the setup and how you can produce your highest productivity. So how you can achieve that with many challenges currently we are facing, or in a normal conditions also we are facing as an organizer, as a manufacturing organizer, many challenges which we are facing in a physical world. So this is the set of virtual factory, and I'm just going to one small video where you can see the how in a this kind of a solutions we can do it in a real way. So this is a 2D of the some of the factory, and on top of it we are uh, keeping the 3D equipments and like say material handling and stations and all. We are creating a one station with all the resources required to do the manufacturing, like robots, fixtures, and this all are we are taking many of them are directly in from the library or say catalog available within the platform, within the solution. So you can see on top of 2D with snapping to 2D itself, we can how I can maintain my 3D layouts, 3D diagrams, and this way I can reach up to my complete factory with the complete line, complete factory setup we can achieve in a. So this is my complete plant in a virtual world. I can set up with all my robots, fixtures, and all the things, product, process, and resources. So next is how I can simulate it, how I can actually analyze it for the real world, from the real world. So this is the small video for that thing where my human, my conveyors, my robots are actually working in a real time scenarios, how it can work, and I can simulate many what if scenarios inside my virtual world. So I can replicate my actual world, my physical world in this, and I can take the results out of it. So this is the virtual factory which is actually running inside my computer, or say inside my solutions. So see the robot movement, what time robot takes, what time machine takes, and the complete process we can simulate, and we can see the effect of this complete process, a single process on a complete line or a complete plant processes. So next is customer case study, where we have one automotive customer, part manufacturer customer case study over here for you to emphasize this particular workflow. So first is as is, or say current process of the assembly line. So we are going to demonstrate one assembly line where with the 8 operations and with respective time for that particular processes with same number of operators. But as a scenario, current scenario, we have a less operators, so just we have shuffled something with the 8 operations with the 7 operators in a, so we just simulating these things. So in a solution for around one shift, which is near about 7.4 hours, and considering the warm up time, means the first product throughput time is around 334 seconds, and after that it goes for a complete shift. So this is the starting point. So as is plant layout, I mean, this is the simple plant layout which we created inside the solution, and here you can see the start point. So I just take my spotlight pointer. So it is here you can see the start point, means start can be a point can where material is from stores, or material is if this is the assembly line, then I can get a material from machining or say other departments in my shop floor. So this is my input station input, and from this workflow is goes in this directions. So I just kept not in a U shape on this, in a this shape. So for the simplicity and for the understanding of layout, we can put some conveyor over here, or we can put it in a U shape for easy material flow also. So it is just a consideration for this scenario. So as is process timings layout, we can say, you can see in the first slide where operation 10 to 80 we have some timings, and here we are doing operation 20 and operation 30 as a one person is doing it, or as a, on a one uh, you can say no one worker is doing this particular operation. So it takes around 105 seconds in summation of both of this, and complete line is going with my 7 workers. So this is something from the customer, you can say, from the practicability of the line. So what we can merge, what we can't merge. So this is something practically possible. So as a sample factory flow simulation, where we done one simple factory simulation. So just run this video for this, so you can better understand how actually it is running inside the software, inside the solution. So you can see the colors are changing, and material is moving from one station to other station. So it is the by the actual time we are running this simulation, what is the process time given. And means green color indicates that something is going on, means my machine is on, or say processing. And blue or purple color is saying that we are waiting for the input, or we are waiting for the output respectively. So you can see the all material is going from one station to other station, and then it takes some time over there for processing, and it's go move forward. So you can see this below this chart, where a processing time is given, waiting input, and from this chart we can easily conclude that what actually station needs to say, or in a particular time. So in a real time we can have that kind of a data, or that kind of a outputs from the simulation. So as is results, so you can see there is some results we pop out at the end of the end of the shift, where for particular operation and particular station. So you can see 247 is my output, and this station utilization is around 23.5 percentage. So each station have their own utilization. And we go to the next slide at the detailed charts. You can see here where you have a detailed pie chart for that particular station, what we see in earlier slide, where you can see the green number is where the utilization. So my operation 20 is utilizing most, because it's has a throughput time, so the highest timing, highest process time it contains. And because of that, maybe other stations are underutilized, so we have to balance the line in a some or other way to do it in a correct manner. So this is, you can see the 93 point, you can say for 94% utilization, and all others are around below 50% utilization. So, and this is the your worker, how your worker is utilized. So this is the report, this kind of reports we can get from the simulation, from the analysis. And this is the observations for first iteration what we run up till now, where bottleneck is created clearly at operation 20, and that we can see in a process chart also, because it is a very simple process which we demonstrate. And because of operation 20, operation 10 and operation 30 is affecting it, that you can say my worker is idle, because of operation 20 has a much amount of process time, and the total shift output also affects, that is around 247 numbers, or 247 parts is out in a one shift. So second iteration what we run, what you can say, as Karthi sir rightly mentioned in their slides, were what if scenarios. So this is my second what if scenario what I am going to present over here. So considering five operators handling the line, means because of current scenario 50% only can come, or say 60% only can come, or say 30% only can come to the shop floor and all. So we consider here the same line with the five operators, and I can say some changes in the machining layouts and all, and simulate the line for same period of time. So this line particularly I am simulating in a warm condition. What is the warm condition means? For an example, your first shift got completed, and your second shift is starting. So when first shift workers had some work in process material on every station, or in say every container, or say every bean, it is something in work in process. So from there my second shift worker will start. So that is called a warm condition in simulation language, what I considered over here. So in first case we consider the start condition, fresh start, and here we start with the warm conditions. So here's is the comparison. So I just put first and second operation as it is, and operation 30 and 40 I just merge. Similarly I just merged 50 and 16, 17 and 80. So this is also a setup what we got from the customer, where you can merge this kind of things, and you can simulate it and got the results of this particular operations. So here, as you can see, on operation third, you can say on third station, you have a maximum throughput time is around 87. So it is, you can call as a tech time in of my line. And this is something, some rough changes to my station, where I just put two tables together, or say on a particular one station my assembly work is doing with the same person, and he is doing two jobs, we can say. So this is the plant layout what after change, and this is the 3D plant layout what you can see. This is the earlier, this is the top view, this is the 3D view of that. And similarly I just run this video for you to, so I just on pop up the chart in this video, so you can see the real-time changes to the this chart when my simulation is running for throughout this shift. So you can see some are green, some are making beans are purple or blue. I'm just running this video because this video is bit long, but yes, it is very much informative regarding to the charts, and pop-up indicators are available with it. So you can see the material movement and man movement also over here. So similar chart we can consider, where this green symbols are, means it is transforming, or say processing, it is working, we can say. And this symbol is, what symbol means, it is waiting for something. So in second iteration results, You can see I got the utilization and output for each and every station over here, and output is around 299 parts. And also in this particular scenario, I just capture the buffer capacity utilization, means I need a extra buffer, or I don't need a buffer over here. I can manage with some small buffer over here, so I can change buffer accordingly on the buffer utilization chart. So this is the pie chart, or say detailed chart for the simulation what we've done. You can say expansion of this only, where you can see all stations are around more than 50% utilized approx instead of this one. And main operation 30, where we see the throughput time of around 87 seconds, which is around fully utilized, or say around 89 maximum utilized this. But still my line is balanced as compared to my earlier example. And here my bottleneck is created at operation 30 definitely. And we observe that operator at operation 10 and 50, you can see operator at operation 10 and 50 is less utilized. So depend on a situation, I can utilize them in some other work, to say some material handling or something, to reduce my manpower in a factory, for as per the social distancing and government norms. Or I can say I have a less worker, so I can utilize them as a for some other work also. So output for the one shift is around 299 parts per shift. So this is the summary of as is complete line details, where we have a complete throughput timings and current as is, as of with seven workers, or the seven men, and 105 is my throughput. So per shift I got a 247 numbers approx. And in a to be analysis, when on a second iteration, what if iteration, I have a 5 mannequins with 87 is my throughput time, and my per shift output is around 299 parts. So this is, you can see clearly where my parts are getting, my output is getting higher as compared to earlier stage. So this is the one-to-one comparison. When you compare the as is manpower and to be, means 7 and in first iteration we have a 7 workers, and to be we have a 5. And in the first iteration we produced 247 number of parts, and in second we produced around 299 parts. So in this particular case we have achieved productivity increase approximately 69 percentage. But yeah, this is something, a scenario what we created for understanding the solution, understanding the software. But in a real world actually we have many ideas. Means for an example, in a process planning or say production department or say manufacturing engineering department, we have around 5 6 or 10 staffs are there. So everybody has a different ideas to optimize the production line. And if there is a small change in a production line, it may affect the complete line or a complete plant. So that we can uh, check all that particular ideas, all that particular you can say ideas we can have inside the so virtual twin, and we can actually simulate them as it is in a real world. And we can check if we do this small change, how it affects to my complete line or complete plant. So this can be done in a batch production, that can be done in a discrete event, discrete productions, or say line builders can simulate that for their customers and all. So there is many applications we can see for this kind of the solutions. So this is the typical workflow, where what I have done in a software is a simple thing which I taken a 2D layout, or say simple whatever layout is available or not available with or with actual photos and dimensions. I can create a plant layout of my on 3D plant layout of my complete plant and systems, and I just take a create a stations line, and give them a behavior, give them a particular flow to them as it is actually running, and what to be in my idea also I just put over here. After that I just play the simulation for particular time. I can play it for 5 minutes, 10 minutes, 1 hour, or say one day, one shift, 1 week, 1 year. It is depends on me, what is the predictions I have to make from this kind of a simulations, and what is my live KPIs. So you can check the live KPIs over here, and again you can change the parameters, again you can change your layout, again you can change the flow, you can change or implement any different ideas over here, and you can reiterate the resimulate the complete simulation and have some different results, and work with the optimum results over here. So overall solution benefits means, what is the benefits I got from this kind of a software's implementation, or say from this kind of a technology implementation. What is it? First time right, whenever you go to your shop floor, you whatever changes you do, that is the first time right. Not you have to change, we can't in an actual production line we can't change many things uh, in a frequent way, because my production got hampered because of that things. Discrete event 3D simulation we can do. So this is the discrete event simulation on my 3D objects definitely, and validate the behavior of a station or line or a complete plant. So definitely I can do the very much early validation, means my if my I am having some greenfield project, so manufacturing process planning, at the process planning stage only I can validate the complete plant inside my virtual world, and I can simulate the AGVs, I can simulate the conveyors, many fixtures, robots, everything what kinematically can be moved, I can simulate here. So AGVs are also one of the thing which is predominantly we can do that. Simulate multiple what if scenarios. What if scenarios means I can actually run my all kind of the ideas, all kind of the concepts, all kind of the you can say breakdowns and sudden absenteeism also I can simulate over here. Say for an example, I have a 2 or 3 machines for a one work. If one machine got breakdown, or say I have a 10 workers on a line, my only 6 workers are available on that day. So what is my plan, what is my ready with me, something ready with me. So we can simulate that kind of a situation inside the solution. Generate reports and detail statistics to make informed decisions. So you can report, you can submit to your clients, you can submit to your management, and we can coordinately take the informed decisions before my plan going to be start, or it is established.
Yeah, thank you, Chirag.
Welcome, sir.
So, Chirag, thank you for taking us through the entire, one customer scenario and showing comparing the two scenarios, as if scenario as well as the 2D scenario, and articulating the digital platform, how it is going to, address the different challenges being faced by the industry. So coming to the platform, here I would like to talk, predominantly we focused in the previous slides on the digital manufacturing solutions. So before getting into the details of the digital manufacturing solutions, I would like to emphasize the platform, the 3D experience platform, where the complete platform is having the multiple brands. It's an integration of multiple brands. I can even say can be used like our Android OS, where you have multiple apps. Plenty of apps can be downloaded, installed, and run through the different usages or different purposes. So similar way, our 3D experience platform is going to have the multiple brands in place, which addresses almost 11 industries of various requirements. For example, I can say the aerospace segment, I can say the automotive segment. We are having very good footprint in terms of the shipbuilding, high-tech equipment, so whatnot. I can say almost 11 industries. So how we are going to address all these 11 industries with a single user interface? So if you look at way back, the challenges what we used to have, the multiple solutions, multiple brands, and the multiple CADs and the multiple manufacturing solutions, which is very tedious to handle by any organization to implement, to handle, and to collaborate. So to overcome those challenges, Dassault Systems has brought this 3D experience platform, a single unified solution. So you can see here the center of the slide, you can see the compass. So where we are trying to split our portfolio as a four compartments. Left side of the compass, we are going to talk on 3D modeling gaps, where we are all very familiar, like Katia is a very popular brand and it has got a very good market footprint in different verticals. And BioVia, there is a no, again it is predominantly we want to address I can say some of the engineering and research solutions. So BioVia is going to take a major role to address the research oriented products. So that is one new product is being added in the platform. And then we have GeoVia solutions to address the different mining requirements. And we are all familiar with the SolidWorks again. So downside of the compass, I can say bottom side of the compass, we are talking about the V plus R, where there is a 3D VIA brands as well as the Similia and DELMIA brands. So 3D VIA again, it is predominantly addressing the modeling needs and publication needs of the industry. Similarly, again, realistic simulation. So whatever the virtual simulation we are talking about, we also need things need to be as a realistic comparison. So where Similia can address the different dynamic conditions of the product and the dynamic environment. So whereas DELMIA, we are today's session we are predominantly focusing from the beginning on the DELMIA as a one of the key manufacturing solutions here. And right side of the compass, we would like to emphasize again, all this we are talking about the modeling, we are talking about the simulation, and what about the product once it gets released. So let us say it's not just creating the product, we need to see how product is being accepted in the market, or different different mindset of the people, different mindset of the industries. So I want to have that market information in my fingertips, where Exalead and NetWorks is going to add in a single dashboard environment. I can see the statistics of the products being launched or marketed, or even I can use these tools to investigate, market intelligence information to innovate my products too. So on top of the compass, again, we are talking about the social and the collaborative apps. Predominantly the Unovia, which is key layer underlying platform what we are talking on the PLM. So beginning to end, the complete life cycle of the product can be collaborated by the Unovia platform. And you can see there is a right side, you can see the 3D Excite. So this is one of the, I can say, the new features from Dassault portfolio. It's a new acquisition. So this is going to address again, once I created the product, once I created the, engineered the product and launched the product, it should be sold in the market. So 3D Excite is allowing all the marketing and the sales departments with real-time realistic simulations as well as the real-time experiences. So that helps to position the product well in advance and with the minimal efforts in real-time scenario. So that is a key advantage using the 3D Excite platform, and it has got very vast subject to work with our engineering current data. I mean, I'm not going to create any new data. I can use my existing engineering data to create the experiences which can suit marketing as well as the sales requirement. Next slide, Chirag. Yeah, thank you. So the today's session predominantly we are focusing on the V plus R, and the ultimate goal is to reduce the distance between the virtual as well as the real environment. So how we are going to fulfill that requirement is with our broad portfolio. So we want to categorize, we are categorized our platform, especially from the V plus R perspective, as a three layers. So one is on the modeling perspective, I mean to model, so model the environment and optimize that, and then you can see the performance of the plant. So when we look at the digital manufacturing solutions, we have the various areas to address. So today's session predominantly focusing on the top layer, on the process engineering as well as the factory floor simulation, where we also have the solutions to address the different machining requirements, which is fabrication comes under the portfolio of fabrication. And then we have the ergonomic simulation. It is not just that you create and simulate the plant. We also need to validate the ergonomics requirement of the product or plant. So ergonomics can be classified as two areas. One is on the engineering front, and the second is on the manufacturing front. So many countries, the ergonomics, I mean worker safety, worker efficiency, and worker comfort makes a lot of sense. So industries will adapt the ergonomic solutions again to fulfill these standards. I mean different industry standards and government norms. So again, robotics. So today, Chirag is highlighted the basic information on the robotics. However, we are also coming up with one session next week on predominantly focusing on these two areas like ergonomics as well as the robotics area. We request to you to get registered and join this session where we are going to emphasize more on ergonomics and robotics related capabilities being addressed from DELMIA brand. So next comes to the optimize. So it's not just creating the plant, how I am going to use my tools effectively to optimize the plan, though it is the master planning or it could be a transportation planning or workforce planning or even the sales operations planning. So everything can be considered as under the optimization layer where we have the different solutions to address these needs. So next is the perform, and today we are having a very key word, Industry 4.0, and people is talking about the smart factory. So with the perform layer, we are able to fulfill the requirement of Industry 4.0, where the complete operations. I am not just talking one plant, multi-plant scenario and the multi-product scenario. I can say there is a lot of complexities in the production environment always. When you look at the single product environment or single plant environment, there were many complexities with respect to the tools, with respect to the operations sequences and the machines and resources. So to overcome all these challenges, we have different solutions to address the lean manufacturing. This is the one of the, I can say, one of the key focus area of DS to monitor the complete plant information or machines information in a single dashboard and try to enhance the efficiency of the machines as well as the operator. So similar way, we have the different products under this portfolio, which is state-of-the-art solutions from the production planning perspective, as well as the operations perspective, manufacturing engineering solutions perspective. So here the idea is we may be using the IoT and IIoT capabilities of the capabilities to integrate all these solutions and place well placed in the complete engineering to manufacturing scenario. So Chirag, request to go for next slide. So here I would like to talk. So we were speaking about the all three layers of our platform from the V plus R perspective, that is DELMIA brand perspective. Now we are in the current scenario, we understand the customer business challenges, and we had a multiple iterations to derive this offers to meet your immediate requirements. So there is a four categories predominantly available under this offer. One is on the machining side. So let us say, I can say one example I will take here. Probably maybe using X machining software, or maybe using the traditional way of programming your machines. It could be a 2D, I mean, turning machines or milling machines. Now we are going to offer under this promotion is the even up to 5-axis capabilities. So even you can see, look at the Milton machine programmer capability, and what we are trying to do here is with minimum investment, you can reap the benefits of these expensive solutions at very reasonable cost during this promotion. So apart from the standard offers, what we do in the normal scenario, these are the offers which we are coming up under the cloud solutions, where the implementation is very minimal, and hardware requirements is also very minimal, and quick to deploy and use the solutions. From the process planning roles, so today whatever the Chirag is covered, those roles also available under the promotion, which can be packaged based on the needs, understanding your current plant needs. We will be deriving the optimized bundle, customized bundle to suit your requirement. So, and also we have the factory floor simulation roles. It could be a combination of process engineering roles. So put together, we can customize these two packages and provide. With any companies having even the robotics requirement, so again, robots, if you talk the independent robots, you may have the programming capabilities inside the any robot what you buy. But however, if you have the multi-robotic plant environment, then definitely our solutions is going to add the value by handling multiple robots programming capabilities, which addresses the different areas of the plant as well as the automation. So, for example, you can see here the body in white robot programmer, which is exclusive to the automotive industry, where complete programming is having a kind of a template. I can say the template is available. You can just use the robots and create the quick programming by using those templates. Similarly, there is a different options available to carry out the welding and the spot welding programs. So those are not part of the promotion, but still we can consider if any request is coming up on those capabilities. So I am at the end of my slide. Chirag, please go to the next slide. So the today's session, ultimately our target is to enhance the efficiency of the plant by adding the virtual capacity. I mean, virtual peaks as one of the basket, and even when I speak to the customers on with the multiple manufacturing customers, if they say even I get a 1% efficiency, your tool is very well utilized. So we get this kind of challenges where today we are trying to articulate a huge difference. I mean, I can say more than 20% efficiency, which is being articulated to one of our customer, where our systems is being implemented and customer reaped the benefits of it. So we are open to the questions and question and answer. We request unmute the session and raise the questions, or you can also raise the questions through the chat box. So I can see one question in chat box. Would like to know timeline for implementation for greenfield project. So I'm not sure on which particular domain he's talking about. If I understand the product, then we could be able to answer this question better. However, it's predominantly there is a multiple factors to carry out the implementation. Ideally, I can say if the data is ready, if you are already in the 3D environment, using the 3D environment and different challenges, implementation should not be a challenge. So, any other questions? So we have provided our mail contacts here, and you can always raise the questions and the queries either to our marketing department or our technical team. So we are happy to address your queries even after the session, and we all thanks to for your participation being spent taking your valuable time and attending this session. And I also request to join the upcoming session on robotics as well as the human ergonomics related session. Thank you.
So, okay, thank you all of you.
Yeah. Thank you.
Thank you, Prahlad sir. Thank you, Karthi sir.
Yeah, thank you, Chirag and Mr. Bharti.